Welcome back. In this section, we'll talk about functions. We're all familiar with functions already from previous math classes. They take an element from a domain set and map it to a specific element in the codomain. Note that that is a specific element. That is one of the basic fundamental requirements in order to be a function. We can use functions to map many different kinds of things. We could map kids to their assigned color of the lollipop. Consider the set K being equal to Annie, Andrew, Zeus, and Zoe, and the set L equal to red, green, blue for the lollipops. We can assign elements from K to L based on the first letter of their name. All A's get blue lollipops, Z's get red lollipops. So I've drawn out all the elements from the domain on the left side here, and the elements from the codomain on the right side. Now all we have to do is assign them. So all of the A's get blue, so Andrew and Annie both get blue, and all of the Z's get red, so Zeus gets red, and Zoe gets red. And this follows the rules for a function because for each input from the domain, I get one specific output in the codomain. Next is function definition. Let A and B be non-empty sets. A function f from A to B is an assignment of exactly one element of B to each element of A. We write f of A equals B if element B is the unique element of set B assigned by the function f to the element A of set A. If f is a function from A to B, we write f colon A and then an arrow B. Note, functions are often called mappings or transformations. Functions can be expressed in many ways. Sometimes like the explicit lollipop mapping we previously covered, and sometimes with a formula like f of x is equal to x plus 1, and sometimes in a computer program function. A function f from A to B can also be defined as a relation from A to B. Recall that a relation from A to B is just a subset of A times B. A relation from set A to set B that contains one and only one ordered pair, AB, for every element A in set A, defines a function from A to B. This function is defined by the assignment f of A equals B, where ordered pair AB is the unique ordered pair in the relation that has as its first element, that has A as its first element. Image definition. If f is a function from A to B, we say that A is the domain of f and B is the codomain of f. If f of A equals B, we say B is the image of A and A is the pre-image of B. The range, or image, of f is the set of all images of elements of A. Also, if f is a function from A to B, we say that f maps A to B. Note that the codomain of the image, Note that the codomain and the image are not the same. The codomain is all possible values, but the image is all mapped values by the function. Two functions are equal when they have the same domain, the same codomain, and the same mapping of each element in their domain to the same element in their codomain. Note that if you change the domain or the codomain or the mapping, then these are different functions. We can graphically represent a function's mapping by drawing a circle for set A, a circle for set B, and then map a point, an element A in set A, to the element B, which is the image of the function f of A. And we can draw a line from A to B. We can also go generically from the set A circle to the set B circle with an arrow here and say that function maps A to B. If we use the lollipop function from earlier, we can list the domain, codomain, range, or image. So let f be the function that maps them, so that f of Zeus equals red. The domain of f is Annie, Andrew, Zeus, and Zoe. The codomain of f is red, green, blue. The range or image of f is red and blue. Note, green was not assigned, so it is not in the image.